Today's lesson is on the first derivative test, and it's used to determine relative extrema. So essentially we're finding min and max points on a function. So I'm going to start by just giving you a sign chart. So I'm not going to worry about an actual function and derivative. We're just looking at the sign chart. So I have x values, and I have sine of f prime of x. So let's say I've got negative infinity to 2 on this interval. F prime of x is negative. At 2, there's a critical point at 0. And then from 2 to 5, the sine of f prime of x is positive. At 5 is a critical point 0. And then from 5 to infinity, the sine of f prime of x is negative. So what does that mean? Okay, so if the sine of f prime is negative, then that means, let's add in a little section here, that on f of x, the original function is decreasing. So at a critical point, that would be slope 0. If f prime has a positive sign, that means f of x is increasing. And then here's a critical point. And then negative would be decreasing. So obviously here we would have a point that would be like a local minimum. And here this critical point would be a local maximum. So two statements we're going to write. The first one, f of x has a minimum point if f prime of x changes signs from, let's see, a minimum is when it's changing from a negative to a positive, from a negative to a positive. And then the opposite, we can say that f of x has a maximum point if f prime of x changes signs from a positive to a negative. So that is the first derivative test. It is showing us where we have minimum and maximum points. So really, this lesson, we're taking exactly what we did yesterday. We've got our intervals, we have the signs, and I'm just adding this right here of f of x. Okay, so first example, let's just start with something simple. F of x equals x squared plus 12x plus 35. So you should know that that's just a basic quadratic that would open up. So we're going to have a minimum point. But let's just go through the process and figure out where that is and how we can justify that. Okay, so we first want to take the derivative. So 2x plus 12. We want to find critical points. So we're going to set the derivative equal to 0. And we're going to have x equals negative 6. Now we need to make a sign chart. So I'll have the intervals of the x, the signs of derivative, and then I'm just adding to the sign chart of what is happening on f of x. Okay, so intervals would be negative infinity to negative 6, and then negative 6, and negative 6 to infinity. So derivative is 0 at negative 6. And then if we look here at the derivative, plug in a super small number. This would be negative. Super large number, that would be positive. So because the derivative has a negative sign, that means that the original function f of x is decreasing at the critical point. It's slope 0, and then plus it's increasing. So we can see that there would be a minimum point right there. So now your justification is f of x has a minimum point at x equals -6, and that is because the derivative changes signs from negative to positive. Okay, next example. This time I'm giving you the derivative. G prime of x equals x squared minus 5 over x. And for this, so obviously x cannot equal 0. So derivative is just given to us, so let's set it equal to 0. So for this to be equal to 0, we just really care about the numerator. So the numerator would be equal to 0. So then you would add 5, square root. So x equals plus or minus the square root of 5. But we need to consider the fact that x cannot equal 0 when we're making our sign chart. Okay, so my intervals are negative infinity to negative square root of 5, and then negative square root of 5, and then negative square root of 5 to 0, and then 0, 0 to positive square root of 5, square root of 5, and now square root of 5 to infinity. So a lot going on. Well, we know that at positive and negative square root of 5, it's 0, and then at 0, it does not exist. Okay, so here is the derivative function. So what happens when you plug in a very small number? Here it would go positive, but here it would still be negative, so this would be negative. Okay, in this interval, let's just plug in -1. We'll have a negative here and a negative here, which would make this positive. And then does not exist. So if I'm looking at this interval, let's plug in 1. That'll be a negative over a positive, which would be negative. And then plug in a really large number, that would be positive. Okay, so now let's sketch f of x using the sign chart of f prime of x. So here it would be decreasing, 0, increasing. Okay, does not exist. Then I've got decreasing, 0, increasing. So I will have 2 minimum points and no maximum point. So f of x has minimum points at x equals plus and minus square root of 5, and that is because f prime of x changes sign from negative to a positive. Okay, last example, h of x, so this time I'm giving you the original function, not the derivative, equals -2x to the third plus 6x squared minus 3. So let's take the derivative, -6x squared plus 12x, set it equal to 0. I'm going to factor out GCF here. So critical points at x equals 0 and x equals 2. Okay, so intervals will be negative infinity to 0, 0, 0 to 2, 2, and 2 to infinity. So let's look at the signs of f of x. Critical points, it will be 0. Okay, so very small number plugging into the derivative. So when you square, so positive, negative, so that would be negative. And this would be negative, so this would be negative. Okay, in this interval, let's plug in 1. So this will be negative 6 plus 12, so that will go to positive. And then if you plug in a very large number, this would be negative. It actually helps to kind of look at it in the factored form, I think. So this would be negative, this would be positive, and a negative times a positive, so it makes this negative. Okay, so let's sketch f of x. I've got decreasing, 0, increasing, 0, decreasing. So this one I have a min and I have a max. So this was h of x. I guess these should have been h prime and h. So h of x, the original function, has a minimum point at x equals 0 because f prime of x changes sign from negative to positive, and h of x has a maximum point at x equals 2 because f prime of x changes sign from positive to negative. So there is your full lesson on that first derivative test, adding this step here to find your minimum and your maximums. Good luck with the lesson.